So we were getting a common denominator, and everything was over 8. So that would be minus 48 over 8. So what should happen if I actually add and subtract those, 81 minus 189 plus 72 plus 84 minus 48, yes, I get 0. So on this one, the value of p of negative 3 over 2 was 0. So I take 2x plus 3, set equal to 0. I'm dividing by negative 3 over 2. So I want to find the remainder. So I have negative 3 over 2. And I use the numbers for the p of x. So that's 2, 7, 4, negative 7, and negative 6. And we're just trying to find the remainder. So we bring the 2 straight down. Negative 3 over 2 times 2. The 2's cancel, you get negative 3. Add that, you get 4. Negative 3 over 2 times 4. 2 goes into 4 2 times. 2 times negative 3 is negative 6. Add those, you get negative 2. Negative 3 over 2 times 2. 2's cancel. And you end up with a positive 3. Negative 7 plus, I think I was saying times. Negative 7 plus 3 is negative 4. 2 goes into negative 4, negative 2 times. And negative 2 times negative 3 is positive 6. And you add those and you get that the remainder is 0. Now we did all that in hopes that you notice what? What do you see?
The remainder is the same as what it equals.
Yes. If you plug in p of 2 and you divide by 2, that is the remainder. So like if up here you wanted to check, especially this one, so you wanted to check this work and see if 61 was right, you could just plug negative 2 into this equation and you should get 61. So that's what do we notice about the previous examples? The remainder equals p of, I'm going to put the divisor. So whatever you're dividing by, if you plug in that number into the function, those two should equal each other. That is called the remainder theorem. So we're going to write that out a little bit more eloquently. If a polynomial function, f of x or whatever, is divided by a factor, we'll call it x minus a, then the remainder must equal f of a. And that's just what we figured out. It's just written out a little bit prettier. Okay.
Teachers excuse interruption. Select choir is also dismissed to the PAC.
She already said that, didn't she? Yeah, okay. I thought so. I guess it didn't show up. Okay, so number 1. For what value of k will the function p of x have a remainder of 8 when divided by the factor x plus 2? So the first thing we need to do is find out what we're dividing by. So really, our 0, the number that we put in the little box there, is negative 2. And then I'm going to look at these. I'm going to say these, I mean that. And make sure I'm not missing any exponents. And I'm not. So I'm just going to write those down. We have negative 2, another negative 2, a k, and then another negative 2. Wonder if that was on purpose. So we just work it out. Even though it has a k in it, it's okay. It's going to be done the same way. So I bring the first number straight down. And we multiply the number in the box times the number under the line, which is 4. You add those, which is 2. Number in the box times the number under the line is negative 4. Now when I add those, I can't really add them. It's just k minus 4. Number in the box times the number under the line, so we have to distribute. Negative 2 times k is negative 2k. And negative 2 times negative 4 is positive 8. And then I add these two. Now when I add these two, I can add like terms. So the negative 2 and the 8 I can put together. So that makes it negative 2 plus 6. So I'm supposed to have a remainder of 8. I want to figure out k so that I have a remainder of 8. Well, this is my remainder. So how can I set it up so I'm going to have a remainder of 8? Yeah. Negative 2k plus 6 equals 8. Subtract 6. Negative 2k equals 2. Divide by negative 2. There's our k. So k is negative 1. Then we have a remainder of 8. Okay, same type of problem. See if you can do the next one. Number 2. I'll even tell you what the answer is supposed to be. If you do it right at the end, you should get that k is negative 8. I'm still going to work it out. I just want you to try it.
Teachers excuse interruption. Havante Davis, come to the office. Havante Davis.
I'm pretty sure I would have died laughing if she had asked for select choir. I'm pretty sure. Your teacher would have been dead from laughter. Okay. Who did the bell work today? Was it Steve? Yeah. Just told everybody that watches the video. I bet you a bunch more watches. If you did, you got a bell work answer. If not, bummer.